Hello guys, good evening everyone. Can you able to hear me? Is it live guys? Just message me, confirm it. Good evening everyone. Are we live now? Are we live now guys? Can you able to hear me? Can you able to see me? Is it live now? Good evening everyone. Okay, Kundan Gupta, good evening. Good evening guys. Join quickly. So we'll have 3000 practice problem session, and in this session we are discussing permutations and combinations. Advanced problems we'll discuss today. Let me introduce myself for the new students. Myself Praneet Kalyanam. I'm maths educator at Unacademy. I have 10 years experience in teaching IIT-JEE maths. Previously I have worked in Narayana China campus Hyderabad, and before that I have worked in Akash Bangalore. I'm from IIT Roorkee. So in this session, we are going to discuss advanced problems from the topic permutations and combinations. So we already completed binomial theorem and complex numbers in the topic 3000 practice problems. So now this is the last class in permutations and combinations. After this permutations and combinations, we'll start probability. So guys, have you enrolled for Unacademy Combat Test Series? This is India's most gamified competition, fortnightly competition. Every alternate Sunday we'll have combat test. So the best questions, best and challenging questions are prepared by the Unacademy educators, India's topmost educators. So challenging questions, you can find the challenging questions, and you can compare your performance with the real-time ranking, and you can find score and accuracy, rank, and your rating. All this you can find it within question by question. You can find out all this, and you can compare with your fellow contestants, and you can compete with them, and you can this is the most gamified challenge ever made in an academy. And immediately you can find the detailed video solutions by the top educators, and you can find score, leaderboard rating, and all awards, whatever awards you have won in this gamified contest. Okay, and you can win the vouchers also guys. Amazon vouchers, you can win it if you achieve rank 1, rank 2, rank 3. If you are in below rank 50, you can achieve this Amazon vouchers, gift vouchers you can achieve. And so that is the next Unacademy Combat Test is on November 22nd guys. That is on day after tomorrow, Sunday. So this is for class 11, 12 and repeaters. 11 to 11:45, 45-minute session. In this 45-minute session, you'll have physics, chemistry, maths, 3 rounds of questions of 7 questions each. Maths 7, physics 7, chemistry 7. Total 21 questions in 45 minutes. So you can enroll for any one of these 3 courses. Total 45-minute session. In this 45 minutes contest, 21 questions, 7 questions from each topic, and separate contest for 11th, 12th repeaters, 3 sessions. So there will be scoring guys for so this is a alternative Sundays we'll have this combat test series. Okay, right. So this is a syllabus. You can take the screenshot, or you can pause the video and you can watch the syllabus. You can note down the syllabus otherwise. Right. So everyone enroll immediately. In Learning app, you can find this Unacademy Combat Test Series, and you can enroll with this. In Learning app, you can find it, and you can enroll with this referral code, guys. You can use the referral code whenever you want to enter referral code. You can enter this referral code Praneet10. Okay. Chalo, then let's start. So if you want to join Plus platform, these are the packages, guys. You can use these packages. and you can join Plus platform. You'll get instant 10% discount. Chalo, then this is the first question we have. This is a 2017 advanced question. How many 3x3 matrices with entries 0, 1, 2 are there for which the sum of the diagonal entries M transpose into M is equals to 5? See, this type of question we have done it in mains level also. In mains previous year question also we have done the similar question. M transpose into M is equals to 5 means you take any 3x3 matrix. Any 3x3 matrix you take it and calculate M and M transpose, M into M transpose if you calculate. M transpose into M. So you take matrix, any matrix you take it, M is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. Right, what is the answer? Amit Kumar. Answer is C. Is it C? Anyone else, guys? Can anyone try this question? So just substitute this M transpose here. If you substitute M transpose here and calculate sum of the principal diagonal elements, let's see what we get it. So M transpose is transpose of the given matrix. So we can take it like this: A11, A12, A13, A21, A22, A23, A31, A32, A33 into again same matrix A11 into A12 into A13, A21, A22, A23, A31, A32, A33. So when you multiply this, you don't need to calculate all the elements, guys. We just need to calculate principal diagonal elements. Let's calculate only principal diagonal elements. So when you calculate only principal diagonal elements, let's see what we get it. So first row into first column, when you do that, what we get it? A11 square plus A21 square plus A31 square, we get it. And the remaining two elements we don't want. Why? Because we need just the sum of the diagonal elements only we need. So remaining two elements we don't need to calculate. Okay. Next, second row into second column. If you do it, middle element we get it. So which is A12 square plus A22 square plus A32 square, we get it. And the remaining two elements in this row we don't need. Same way, in the last row, last element we need to calculate. Let's calculate that. First element, second element we don't need. So what we need is third row into third column. So when you calculate third row into third column, so what we get? A13 square plus A23 square. You don't need to do all this, guys, actually. You don't need to do all this. Why? Because for your understanding purpose, in detail I am explaining it. But actually you don't need to do all this. What you can do is simply, when you calculate M transpose into M, sum of the diagonal elements is nothing but sum of the squares of all elements only. If you know that, if you have already done this type of questions earlier, then you can do it easily. So sum of the principal diagonal elements is equals to A11 square plus A21 square plus A31 square plus A12 square, all this, A33 square is equals to 5. He is saying sum of the squares of all the elements, total 9 elements, is equals to 5. And these entries are only 0, 1, 2. So what is the possibility we have? One possibility is 1 square plus 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 0 square plus 0 square. Remaining all these are 0 squares. This is one possibility. You get 5. What is the other possibility we have? Other possibility we have is 1 square plus 2 square plus 0 square plus 0 square plus so on up to 0 square. This is also you get 5. Any other possibilities other than this? That's it, right? So these are the only possibilities. So tell me how many possible ways we can make this 5 ones. So this is the first case. Let's see how many cases we'll get for the first case. In the first case, See, we need to select 5 entries to make it 1. We need to select any 5 entries. So how many ways we can select 5 entries? Isn't it 9C 5 ways? We select 9C 5 ways. Any 9 entries we select it and we make it 1 1. Remaining all will be 0. So 9C 5 ways we can make it. Next, second case. Let's see the second case. Second case, how many cases we will get it? Any 2 entries will take it, and those 2 entries, how many ways we will select those 2 entries? 9C 2 ways we can select 2 entries. So in that 2 entries, we need to put 1 and 2, remaining all zeros. 1 and 2, how many ways we can put in these 2 entries? 2 entries we have selected, 2 positions we have selected. In that 2 positions, we can put it any 2 ways, guys. Guys, is it clear? We can put either 1 2 or 2 1. 2 possible ways are there. So like this. So total 9C5 plus 9C2 into 2. That is the answer. So final answer we get it is, yes, it is live, Gaurav. It is live. So tell me, if you substitute 9C5 plus 2 times 9C2. So you can calculate this. 9C5 is how much, guys? 9C5 is nothing but 9 into 8 into 7 into 6. 9C5 and 9C4 both are same. So I'll calculate 9C4. 4 into 3 into 2. Plus 2 times 9C2. 9C2 is what? 9 into 8 by 2. So 2 cancel. And let's see what we get it. 6 get cancelled. 4 get cancelled 2 times. Now if we calculate all this, let's see what we get it. So tell me, guys, how much we getting it if we calculate all this? If you calculate all this, we get it like this. 9 2s 18. 18 into 7, right? Or 9 into 14, anything is fine. 9 into 14 plus 9 into 8. So you can take 9 common. If you take 9 common, how much we get it? 22 we get it, right? 22 we get it. So 9 22s are how much, guys? 198. So we're getting 198. Final answer, we are getting like 198. So 198 is the answer, guys. Anyone got this answer? 198 is the answer. Everyone understood this, guys. 2 cases we are getting it. One case is 5 entries are 1, remaining all entries are zeros. So that 1 square plus 1 square plus 1 square plus 1 square plus 0 square, we get 5. Or 1 entry is 1, 1 entry is 2. And then remaining entries are 0. In that case also we get 5. And this selecting 5 entries to make it 1. Out of total 9 entries, we need to select 5 entries. 9C5 ways. Out of 9 entries, we need to select 2 entries. And in those 2 entries, we can arrange also between 1 and 2. So total 9C5 plus 2 times 9C2. This is the answer. When we simplify this, we get 198. So 198 is the answer. Correct? So first option is the answer. Clear or not? So these are the possibilities, guys. 2 1 0 0, this is one possibility. 1 1 1 0 0, this is one possibility. You can arrange it like this also. Anything is fine. Correct? Perfect. Samajh gaya na? Perfect. Let's move to the next question, guys. Yeah, this is the next question we have. This is 2017 question, 2017 advanced question. Start doing this question. The set S consists of 9 elements 1 to 9 and K is equals to 1 to 5. Let Nk be the number of subsets of S, each containing 5 elements, out of which exactly K are odd. Silly mistake. Okay, no problem. So guys, do this question. Amit, do this question. Complete this question. Number of subsets of each containing 5 elements, out of which exactly K are odd. So let's calculate N1 first. Let's calculate N1 first. What is meant by N1, guys? Let's see the definition of N1. N1 be the number of subsets of S, each containing 5 elements, out of which exactly one element is odd. So out of this 5 elements, we need to select 5 elements. Out of 5 elements, one element should be odd. One element should be odd, guys. So how many possible ways we can select this odd number? See, out of this 1 to 9, how many odd numbers are there? 5 odd numbers are there. How many ways we can select one odd number? Out of this 5 numbers, only one odd number should be there. How many ways we can select it? Isn't it 5C1 ways? We need to select one odd number. N1 means what? N1 means number of subsets of S, each containing 5 elements. So we need to select 5 elements. Out of this 5 elements, only one element should be odd. So we need to select one odd number out of 5 odd numbers. Why? Because 1 to 9 in set S, we are having 1, 3, 5, 7, 9. 5 odd numbers are there and 4 even numbers are there. 2, 4, 6, 8. These are odd numbers and these are even numbers. 5 odd numbers and 4 even numbers are there. So how many ways we can select one odd number? 5C1 ways. How many ways we can select 4 even numbers? See, why? Because this is odd means remaining all these are even numbers only. How many ways we can do this? Isn't it 4C4 guys? Isn't it 4C4? Yes. So the N1 is 5C1 into 4C4. So same way, can I calculate N2? What is N2 guys? N2 is nothing but we need to select 5 numbers. Out of these 5 numbers, 2 odd should be there and 3 even should be there. How many ways we can select 2 odd numbers? 2 odd numbers, how many ways we can select? Out of 5 odd numbers, we can select 2 odd numbers in 5C2 ways. And out of 4 odd numbers, we need to select 3 even numbers. This is what we're getting it. Correct now? Right. Next, N3. Same way we can calculate N3 guys. Let's calculate N3 then. If you calculate N3, how much we get it? Let's calculate N3 here. N3 is equals to, again we need to select 5 numbers, but out of this 5 numbers, 3 numbers are odd and 2 numbers are even. So tell me guys, how many ways? Same thing. 5C3 into 4C2. Clear? And then same way we can calculate N4 also. Let's calculate N4. N4 is equals to, again we need to select 5 numbers. Out of this 5 numbers, 4 numbers are odd and 1 number is even. No arrangement guys, there is no arrangement. Only sets he is asking. Order of the elements does not matter. There is no arrangement. So that's why we are only selecting it. So tell me how many ways we can do this. So out of 5 odd numbers, we need to select 4 odd numbers, and out of 4 even numbers, we need to select 1 even number. This is N4. Same way we can calculate N5. What is N5? N5 means all 5 numbers should be odd. All the 5 numbers should be odd. See, there are total 5 odd numbers are there. Out of these 5 odd numbers, we need to select 5 odd numbers. That's it. So now let's calculate all this. If we calculate all this, this is 5 into 4C4, which is 5. And this is what? 5C2 is 5 into 4 by 2, which is 10. 10 into 4, 40. This is 40, we're getting it. And what about this? 5C3 is 5 into 4 by 2, which is 10. 10 into 4C2 is 4 into 3 by 2, which is a 6. So 10 into 6, which is 60. Next, N4. We are calculating N4. What is the answer, guys? Anyone done this? 5C4 is same as 5C1. C hoga na? Okay, chalo, let's see. 5C4 kitna hai? 5C4 is 5 only. 5 into 4, 20. And 5C5 is 1. So now add all this. If you add all this, 126 we are getting it. 126. That's the answer. So third option is the answer. Correct or not? Understood now? So N1 is nothing but number of subsets of S which contains 5 elements. Out of this 5 elements, 1 odd element and 4 even elements. N2 means all the possible 5 subsets containing 5 elements. Out of this 5 elements, 2 odd numbers and remaining even. Same way N3, 3 odd numbers, 2 even. N4, 4 odd, 1 even. N5, all 5 odd. Clear now? Brijesh, test analysis. Definitely. Analysis will be there. if you have any doubts now, whatever doubts you have, you can able to clear in your doubt clearing sessions and analysis sessions. Okay, right. So otherwise now guys, you do one thing. If you have any doubts now, whatever doubts you have in maths, in IIT-JEE mathematics, whatever doubts you have, every Friday evening I'll conduct a special class on doubt clearing session, guys. There is a doubt clearing session. It's a free session, guys. It is a special class. Every Friday evening, 4 p.m. or 6 p.m. we'll have a doubt clearing session. Whatever doubts you have, whether you have doubt in your test, whether you have doubt in your practice or in your DPPs or in your practice sessions, whatever doubts you have in maths, you can come and join this doubt clearing session. All your doubts get cleared. Okay, you don't need to worry about your doubts. Just come to this doubt clearing session every Friday. So Saturday to Thursday, whatever practice you have done and whatever doubts you have done it, you just save it. Take a screenshot of your doubt and crop it and save it, and come to Friday special class doubt clearing session. You can clear all your doubts. Okay, right. Yeah, these are the N1, N2, N3 values we are getting it. N1, N3, N4, N5 values we're getting it. So if you add all this, we get 126. Clear? So guys, these 3000 practice problems, are you able to download the notes? Are you downloading the notes? If you miss any class, you can go back to whatever class you missed and you can download the notes and you can watch the session, YouTube session, and you can able to download. I'm providing solution for each and every question. So you can download it and you can keep it as in a folder. So whenever you want to revise it, you can go back and revise it. Chalo, let's move to the next one. This is 2016 advanced question. Guys, start doing this question. A debate club consists of 6 girls and 4 boys. There are 6 girls and 4 boys. A team of 4 members is to be selected from this club, including the selection of a captain. So in that 4 members, captain also should be there. If the team has to include at most 1 boy, at most 1 boy means what? Maximum 1 boy. Then the number of ways of selecting the team, maximum 1 boy. So out of 6 girls and 4 boys, we need to select 4 members, including a captain. So this team consists of, then this team has to include at most 1 boy. Maximum, at most means maximum 1 boy. So 1 boy or 0 boy. So either we can select 1 boy, 0 boy also we can select it. So as we need to select 4 members total, so if already 1 boy is selected, 3 girls we need to select it, or 4 girls we need to select. Correct? So tell me now how much we getting it. Total how much we get it, guys. Either we should select either first case or second case. First case means what? Out of 6 girls we need to select 3 girls, or out of 4 boys we need to select 1 boy. This is one possibility. And what is the other possibility? Other possibility is 6C4. Out of 6 girls we need to select 4 girls, and out of 4 boys we need to select 0 boys. These are the possibilities we are having, right? So now tell me how much we get it, guys. 6C3 is how much? 6C3 is 6 into 5 into 4 by 6. 3 factorial is 6. So 6 get cancelled, and 4C1 is what? 4 plus 6C4 is what, guys? 6C4 is same as 6C2. 6C2 is 6 into 5 by 2 into 4C0 is anyway 1. So now let's calculate this. How much we get it? So here 6 and 6 is getting cancelled. So 420s is how much? 80, right? 80 we are getting here. And here what we are getting, guys? 15 we are getting it. So total 95 we are getting it. So that's it. Simple. 95 is the answer. Correct now? Thank you, Amrit. So simple, very simple. Isn't it look like advanced question only, guys? Isn't it? So that's why answer is wrong. Isn't it? Let's see what is the answer actually. At most one boy. So one boy, three girls or four girls. This is only selection, but after selecting, we need to select captain also. Correct. So into four, we should do it. Correct now? That's the mistake we have done. So that's why it is advanced problem. Clear? So 95 is only selection of four members, but out of selection of four members, we need to make a captain. Once we select four members, this is going to be 95, correct? Whatever we have done till here, it is correct. But out of this 95, out of this four members we have selected, we need to select one captain. Now. So captain means what? Out of this four members, we can select any captain. So four ways. So into four, we need to do it so that we get 380. So that's why first option is the answer. Clear now? Guys, is it clear? Where we have done wrong. Understood? Right. Chalo, let's move to the next one. Yeah, this is the next question we have. Let n greater than or equals to 2. This is the integer. Take n distinct points on a circle. Join each pair of points by a line segment. Color the line segment joining every pair of adjacent points by blue and rest by red color. If the number of red and blue line segments are equal, then the value of n. Okay, let's take it this way. Let's take a circle like this. There is a circle something like this, okay? And then, so there are n points are there. So let's take n points here. Something like this. There are n points are there. These n points we need to join by using color lines. What are these color lines? Either red color lines or blue color lines. Every pair of adjacent points by blue color line. So let's take the blue color line. So with this adjacent sides we should join by using blue color line, guys. Like this. We are joining with the blue color line. See here. Blue color line. And the remaining all possible ways we can join with red color. So like this. Like this. Like this. There are so many lines are there. You don't need to draw all this. Just for your understanding purpose, I am drawing the lines. Clear? So what he is saying is all these red color lines are nothing but diagonals. Red is equals to diagonals, guys. Diagonals of polygon. Okay, what is blue here? Blue is number of sides only. Blue is nothing but sides of a polygon. So now tell me, in a polygon of n-sided polygon, how many sides are there and how many diagonals are there? What is the formula to calculate sides and diagonals? So what he is saying is the number of red and blue color line segments are equal. So number of blue color lines is n. N sides are there. Correct. If n distinct points are there, we are making a n-sided polygon. With n-sided polygon, we get n sides. So n sides are we getting it. And how many diagonals? What is the formula to calculate diagonals, guys? N into n minus 3 by 2. That is a formula to calculate diagonals. N into n minus 3 by 2. Right. So now these two are equal. So we can solve this. N cancel and we can able to calculate n value. How much we getting, guys? So n minus 3 is equals to 2 and n is equals to 5. That's what we're getting it. So n value is equals to 5. Clear? Very simple. Number of diagonals. So this is 3, guys. Number of diagonals. What is it? This is not 3 only. Okay, whatever it is. Leave it. Just leave it. He done it in different way. But anything is fine. So guys, clear? n into n minus 3 by 2 is the number of formulas. So if you simplify this part, we get n into n minus 3 by 2. You can remember it as a standard result. Number of diagonals in a polygon is n into n minus 3 by 2. Clear now? Right, perfect. Chalo, let's move to the next question. Yeah, this is the next question. This is 2018 question. So guys, start solving this question. So we need to calculate the number of 5-digit numbers which are divisible by 4 with these digits from the set 1, 2, 3, 4, 5, and the repetition of digits is allowed. Repetition is allowed, guys. See, it should be a 5-digit number. It should be a 5-digit number. So if a 5-digit number is divisible by 4 means what? Last 2 digits should be divisible by 4, correct or not? So last 2 digits should be divisible by 4 means what are the possibilities we have? 1, 2 we have, 2, 4 we have, 1, 2 we have, 2, 4 we have, and then what we have, guys? 3, 2 we have, and then 4, 4 we have, and then 5, 2 we have. Any other possibilities, guys? What is the answer, Charan? 625, correct. 625 is correct. 1, 2 we have, 2, 4 we have, 3, 2 we have, 4, 4 we have. Any other possibilities, guys? That's it, right? 2, 4, 3, 2, 4, 4, and 5, 2. That's it. These are the possibilities we are having. So for each and every possibility, let's assume that here 1, 2 is there. Here how many possibilities are there, guys? Here it is like 5 into 5 into 5 only, right? Which is 125 cases for this and 125 for this and like this. Total how many? 5 into 125. These many cases we are having. Total 625 cases we are getting it. Correct? That's it. So answer for this question is 625. Clear now? Perfect. Chalo, let's move to the next question. Yeah, these are the numbers we are getting, guys. Last 2 digits should be either 12, 24, 32, 44, 52. Why? Because the digits are getting repeated. Remaining 3 digits, we can take any one of these 5 digits. We can take it 5 into 5 into 5. Next, 6th question we have. 2017 advanced question. So guys, start solving this question. Words of length 10 are formed using the letters A, B, C, D, E, F, G, H, I, J. Yeah, total 10 letters are there. So we need to calculate 10-letter word. Let X be the number of such words where no letter is repeated, and Y be the number of such words where exactly one letter is repeated twice. No other letter is repeated. Okay, so let's calculate this. So first let's calculate X, guys. What is X here? X is equals to number of such words where no letter is getting repeated. All letters should come exactly one time only. In that case, how much we get it, guys? Isn't it 10 factorial? X is equals to 10 factorial only, right? Out of these many letters, 10 letters, and how many ways we can make 10-letter word? How many ways we can make it? We are just arranging these 10 letters. How many ways we can arrange these 10 letters? 10 factorial ways only. Okay. We got X equals to 10 factorial. And what about Y, guys? Let's calculate Y also. What is Y? Y is equals to number of such words where exactly one letter is getting repeated. One letter is getting repeated twice. That means what? Let's assume A is getting repeated. If A is getting repeated, A, B, C, D, E, F, Z, H, I. That's it. These are the letters we should take it. Why? Because if one letter is getting repeated means one letter should get missing. So what is that letter? Z. Z is getting missing. So A is repeating twice and J is missing. So now tell me how many ways we can arrange these total 10 letters. These 10 letters we can arrange it in 10 factorial ways, but here A is repeating. So because of that, we need to divide with 2 factorial. That's what we're getting it. Now tell me what he's asking. Y by 9x he's asking. Let's calculate y by 9x. Y by 9x is equals to, y value just now we calculated 10 factorial by 2 factorial into 9x. That is 9 into 10 factorial. So 10 factorial cancelled, and we're getting 1 by 18. Correct now? Is it correct? One letter is repeated twice and no other letter is repeated. Number of such words of length 10 only, right? Correct now? So 1 by 18 we should get it. So we are not getting 1 by 18. Somewhere we did mistake. Let's see where we did mistake. Yeah. Actually here what we have done here is, we didn't select A, guys. We need to select A also. So out of 10 letters, we need to select one letter. How many ways we can select? 10C1 ways we need to select it. Correct or not? See, it can be A, it can be B, it can be C, it can be anything actually. It can be anything that is repeating. So one letter has to repeat twice and one letter has to miss. So one letter which is repeating is a 10C1. And one letter has to miss. How many ways one letter has to miss, guys? One letter has to miss how many ways? Isn't it 9C1 ways? Why? Because whatever letter is getting repeated, that letter should not be missed. Other than this A, remaining 9 letters, one letter should get missed. So 10C1 into 9C1. Now you substitute this value, guys. Y value is 10 into 9 should come. So here 90 should come. 90 means what? Total 5 should come. So that's it. That's how 5 is the answer. Correct or not? Everyone understood. Let's discuss this question again. So with this 10 letters, we can make no letter is getting repeated, means all the letters should come exactly one time. That is 10 factorial. And what is y? Y is the number of such words where exactly one letter has to repeat. So exactly one letter has to repeat and no other letter has to repeat, means one letter has to repeat and one letter has to miss. One letter has to repeat means out of this 10 letters, any letter can repeat. So maybe 10C1. So out of this 10 letters, already one letter is repeating. That letter we can't miss it. Other than that letter, remaining 9 letters, one letter should get missed. So here J is missed. See here. So 9C1. So 10C1 into 9C1. So if you substitute this value y here, y by 9x equals to 5. That's what we're getting it. Clear? So 5 is the answer. Correct? Perfect. Chalo, let's move to the next question. Yeah, this is the next question we have. 2015 advanced question. So guys, start doing this question. Hello Manas. So n be the number of ways in which 5 boys and 5 girls stand in a queue in such a way that all the girls stand consequently in the queue. Okay, let's calculate first n value. What is n value? Number of ways in which 5 boys, 5 girls stand consequently in a queue. Stand in a queue in such a way that all girls stand consequently in a queue. All girls has to sit consequently means these girls we need to make a bundle. Correct. All integer type questions only we are getting on permutation and combinations. So all 5 girls we need to make a bundle. If you make all girls in a bundle, how many ways we can rearrange them in that bundle? 5 factorial ways we can rearrange it. But we'll consider this one bundle as only one person. This bundle we consider it as only one person. So total how many persons are there? 6 persons are there. These 6 persons, how many ways we can rearrange it? 6 factorial ways. So n is going to be 5 factorial into 6 factorial. Clear? Everyone understood this? All the 5 girls should be together. So what we'll do is, we'll make this 5 girls as a bundle, and we'll consider that bundle as only 1 unit, and in that 5 bundle, these 5 girls can be arranged in 5 factorial ways, and including that bundle, total 6 members are there. These 6 members can be arranged in 6 factorial ways. Okay, n is equals to 5 factorial into 6 factorial. Now let's calculate m value, guys. What is m value? M be the number of ways in which 5 boys and 5 girls can stand in a queue in such a way that exactly 4 girls stand consequently in queue. Exactly 4 girls has to be sit consecutively. Okay, let's see this. 5 boys and 5 girls are there. Out of this 5 boys and 5 girls, exactly 4 girls should stand consecutively. Exactly 4 girls stand consecutively. So what we'll do is, we'll make 4 girls in one bundle. Is Singe good for calculus? I have zero confidence in it. I have my coaching notes and plus. How should I proceed? See, if you have enough time to complete Singe, then you go for Singe. Okay, Singe calculus, if you want to go, what you can do is, if you have enough time to complete the Singe, then you go it. Otherwise, what you can do is, you can start solving your coaching material, your coaching notes or whatever, and then start solving previous year questions. Still, if you have time, then go for Singe. Okay, right. So guys, 4 girls has to be consecutive. Exactly 4 girls has to be consecutive. So what we can do is, first we'll arrange boys. How many ways we can arrange 5 boys, guys? 5 boys can be arranged in 5 factorial ways. Is it correct or not? 5 factorial ways we can arrange 5 boys. And we'll choose any 4 girls. How many ways we can choose 4 girls? 4 ways we can choose 4 girls. Okay, let's assume that we selected Z1, Z2, Z3, Z4. We selected this. So now what we'll do is, we'll bundle it. We'll bundle them. Clear? When we bundle them, what will happen? How many ways we can rearrange them? How many ways we can rearrange this Z1, Z2, Z3, Z4? 4 factorial ways we can rearrange it. Okay, we rearranged it. So now how many numbers are there? 1 girl is there, that is Z5, and another set of girls is there. That means another group of girls. So now we consider these two as 2 elements only. Z5 is 1 element, and Z1, Z2, Z3, Z4, that bundle we call it as 1 unit. So there are 2 units only. How many ways we need to put these 2 units? Total how many places are there? 1, 2, 3, 4, 5, 6. In these 6 units, we need to put these 2 units. How many ways we can do that? Isn't it 6p2, guys? Why? Because we need to select any 2 positions, and we need to arrange also. Selection plus arrangement. So 6p2. So that's what we're getting m value. So tell me, what is it? I think we can simplify this, guys. 5c4 is 5 only. So this is 5 factorial only. So 6p2 into 5 factorial. And again, still you can simplify this. 6p2 is what? 6p2 is 6 into 5 into 5 factorial into 5 factorial. So which is total, how much we get it? 5 into 6 factorial into 5 factorial, we get it. So finally we are getting 5 into 6 factorial into 5 factorial. Now what he is asking, m by n he is asking. Let's divide these two. If you divide these two, how much we get it, guys? How much we get it? M by n is how much we are getting it? M by n is equals to 5 into 6 factorial into 5 factorial by 5 factorial into 6 factorial. These two get cancelled and we're getting 5. So 5 is the answer. 5 is the answer. Guys, is it clear? Everyone understood this? Right. Any doubts in this question? This is very good question, guys. So exactly 4 girls has to be together, so that 4 girls and other girls should not be together. So that 4 girls, we bundle it, we selected and we arranged it and we bundled it, and these 4 girls and the remaining girls should not be together. And first we arranged boys. In between boys we got 6 places. These 6 places we arranged this 1 girl and a bundle of 4 girls. So two members, guys. We consider it as 2 members only. Clear? Got it now? Perfect. Chalo. That's what we're getting it. 5 we are getting it. Clear? Perfect. Next, last question, guys. This is the last question. After this question, we'll end the session. N1 less than N2 less than N3 less than N4 less than N5 be the positive integers such that N1 plus N2 plus N3 plus N4 plus N5 is equals to 20. Then the number of such distinct arrangements. Okay. You didn't understand, Maya? Previous question you didn't understand. Should I discuss again? Okay, chalo. Let's discuss the previous question one more time, guys. N is nothing but number of ways of arranging 5 boys and 5 girls in such a way that all the girls should be together. All the girls should be consecutive. That means all the girls should be together. All the girls has to be together means we need to bundle these 5 girls and we consider it as only 1 unit. Total 6 units are there. These 6 units we can arrange it in 6 factorial ways. But in this bundle again we can arrange it in 5 factorial ways. So n is 5 factorial into 6 factorial. But what about m, guys? M means m is the number of ways in which 5 boys and 5 girls can be stand in a queue in such a way that exactly 4 girls should together. So exactly 4 girls should together means this 4 girls and this 1 girl should not be together. So what we'll do? First we'll select 4 girls. How many ways? 5C 4 ways. And then we arrange it. In that bundle, we'll select 4 girls and we'll bundle them. In that bundle, we can arrange them in 4 factorial ways. So 5C4 into 4 factorial. So there is 2 elements are there here. One single girl and there is a group of bunch of 4 girls. And these 2 elements, that means this girl and this 4 girls should not be together. So that's why we are arranging boys first. How many ways we can arrange boys first? 5 factorial ways. If you arrange boys first, in between boys 6 gaps are there. In these 6 gaps, we need to put these 2 elements, 1 girl and a bunch of 4 girls. How many ways we can do that? 6p2 ways. Selecting 2 positions and arranging also. So 6p2 into 5 factorial into 5c4 into 4 factorial. This is m. So now divide these 2. If you divide these 2, we get the answer. M by n is equals to 5. Clear? Right, let's do the next question. Yeah, this is the last question we have, guys. N1 less than N2 less than N3 less than N4 less than N5 positive integers such that N1 plus N2 plus N3 sum of the elements is equals to 20. Okay, right. Chalo, let's do this way. See, I will start with minimum case, guys. 1 less than, 2 less than, 3 less than, 4 less than, isn't it? So here we should take a number. So till here it became 10, guys. Till here it became 10. So can I take 10 here? So sum of the elements is equals to 20. We are getting it. This is one case. Clear? Next, what I'll do is 1 less than, 2 less than, 3 less than, 5 less than. How much we can take it? We can take 9. This is another case. Next, 1 less than, 2 less than, 3 less than, 6 less than, 8. This is another case. Next, 1 less than, 2 less than, 3 less than. So if I increase this, then it is also 7 and 7. So we can't increase this. So what I'll do is, instead of increasing this, so starting with the 1, 2, 3, only 3 cases we are getting, guys. If I take N1, 1, N2, 2, N3, 3, only 3 cases I am getting it. So now what I'll do is, instead of taking 1, 2, 3 again, there is no cases for 1, 2, 3. I'll take 1, 2, 4. I will take 1, 2, 4. So this is 1, 2, 4. 1 to 4 less than 5 less than how much? Tell me. Now you tell me. Isn't it 8, guys? This is another case. See, Manas, if you take that n minus 1 c r minus 1, you won't get this increasing order case, you won't get it. You'll get different cases, you get it. Correct or not? Equal case also, you'll get it. 5, 5, 5, 5 case also, you'll get it. 4, 4, 4 case also, you'll get it. Correct or not? So this is easy. Why? Because you won't get much cases, or hardly you'll get 7 or 8 cases. That's it. So let's check it. So how much we get it? Okay. Right. So this case we discussed. Next, what is the next case we can have? So 1 less than, 2 less than, 4 less than, 6 less than 7. This is another possibility, right? Yeah, this is another possibility. Next, 1 to 4 is over, guys. 1 to 4 we can't make it more than this. So after 1 to 4, can we take 1 to 5? Can we make 1 to 5? 1 to 5 is how much? 8. Remaining, how many numbers we can take it? Less than 6, less than 6. No, not possible. Not possible, guys. 6 less than 6 is not possible. So no chance for this. 1 to 5, no chance, guys. Let's remove 1 to 5 then. 1 to 5 is not possible. 1 to 6, 1 to 6 also not possible. So the only possibility we have is now 1, 3. Let's go to 1, 3. 1, 3. 1, 3, 4 you take it now. 1, 3, 4 is 8. So remaining 5 and 5 less than, how much we get it? 8 plus 3. 7 we can take. 1, 3, 4, 5, 7 we can take it. Any other possibility? No other possibility. That's it. Next, after 1, 3, can we take 1, 4? Let's check it. 1, 4, 5, 6, 7. Let's check it. Is it possible or not? No possibility, guys. 1, 4 should not happen. So 1, 4 should not happen. So that means 1, 5 also should not happen. So starting with 1 is over. Now starting with 2, guys. 2 less than, 3 less than, 4 less than, 5. So till now how much, guys? Till now 15 less than 5. No, not possible. Less than 6, not possible. Possible, right? 2 plus 3 plus 4 is how much? 9 only, right? 9 plus 11. Exactly. It is satisfying. This is fine. Clear now? That's it. We're getting it. So any other method, any other cases we are getting it other than this 7? Are we getting any cases, guys? No other cases. Only these cases we are getting it. 1, 2, 3, 4, 5, 6, 7. That's it. It won't take much time to analyze these cases, Manas. It won't take much time actually. We are just starting with the minimum value. We just started with the very minimum value. We just started. 1, 2, 3, 4 we have taken, and the last one we fixed. First 4 numbers we fixed, last one we calculated. First 3 numbers we fixed, last 2 we are changing it. First 3 we fixed, last 2 we changing it. So like that, we are trying to calculate all the possible values, and hardly we got 7 cases only. Okay, so no formula will give you this answer, guys. Just analysis will give you this answer. Correct or not? Right? Clear? So there is an analysis like this, but instead of this analysis, if you make it like this, then it will be easy. This analysis will give you answer easily compared to this analysis, whatever this analysis. Clear? Guys, is it clear? Right. So 7 is the answer, guys. This is a 2014 advanced question. Okay. So that's it for this class. Okay. So see you in the next class, guys. The next class we are going to start probability. So that is on Monday to Wednesday and Friday. Every Monday and Wednesday, Friday, night to 9:30 p.m. There is a YouTube session on this 3000 practice problem. So in this next Monday, Wednesday, Friday, we are going to discuss probability questions. So first we'll start with the 2020 questions. 2020 Jan and September questions, we'll do it. Clear? Perfect. Chalo guys, good night everyone. Take care. So see you in the next session, guys. Bye bye. Take care.